Hello again. Today we're covering section 3.1, lines and angles. Specifically, how can we identify parallel versus skew lines? You've probably heard of parallel before, but this one might be new to you. And then how can we name some angle pairs formed by two lines and something called a transversal? So it's a bit of a vocabulary today, but it shouldn't be too bad. First off, parallel lines versus skew lines. Parallel lines are lines in the same plane that never intersect. So an example would be like this. If those lines traveled forever in that plane and they never intersected, those are skew lines. Now, in a plane, the only way for lines to never intersect is if they're parallel. If they're going exactly at the same angle, right? I can't have one go up and one go down and be parallel because otherwise they'll intersect. See? Intersect right there. I once had a kid try drawing an example like this, like, oh no, Mr. Anderson, what about this? This one's going up and this one's going down and they don't intersect. But of course, lines go on forever in both directions. So this one does indeed intersect, right? It keeps going that way until it crosses. So parallel lines never intersect. So they look like that picture right here, parallel lines. So skew lines are lines in different planes that never intersect. So parallel lines and skew lines, kind of the same concept, except parallel lines are in the same plane. Skew lines are in different planes. So it's harder to draw an example because different planes are going to have to be like in 3D space, but I could try it. So let's draw a cube so we can have a 3D space. All right, if I draw that cube, then we can see we got three-dimensional space going on here. And then I could say, all right, well, let's look at this line right there in red and this line right here in blue. Those ones are clearly not parallel. They're not like both at the same angle, but they're never going to intersect either because they're in a different plane. So lines that never intersect but are in different planes, those are skew lines. Let's give a few of those a try. In this picture, are EF and GH parallel, skew, or neither? All right. Well, EF is right there. GH is right there. Parallel, skew, or neither. Those ones are parallel. You see how they both are on that top plane, but yet they're never going to intersect? That's parallel. Let's try these ones. EF and GC. Well, EF is here again. GC is over here. Those will never intersect, but because they're on different planes, right? This one's on that front plane or the top plane, right? It's where the front and the top plane intersect. And this is where that back plane and the side plane intersect. They are definitely not on the same plane. They're going in different directions entirely, but they aren't going to intersect. This one's going to cross in front of the other one, never actually hitting it. So they're skew. All right. Last one, DM and BC. Well, DM isn't drawn, so we'll have to draw that in. DM would be the one that connects those up. It's kind of like that. It's on that bottom plane. And BC would be this one. Parallel, skew, or neither. Well, I can see that they're both on that bottom plane, so they are on the same plane. So they're definitely not skew, because skew have to be on different planes. But when I follow them, it appears that they will actually intersect, right? They're going to intersect over there. So those ones are not parallel either because they are going to intersect, right? Even if they weren't intersecting at that moment, lines go on forever. That one goes like this. This one goes like this. They are on that same bottom plane, so they will intersect right there. So those are neither parallel nor skew. They're going to intersect. All right. Last thing today is we're going to, oh, sorry, not last thing. We're going to also talk about symbols for parallel lines. So in the picture, AB appears to be parallel to CD. Like if I look at this picture over here, they look like they're parallel, right? They look like they're both going at that same angle. But how can we tell for sure? Maybe they're just a little bit tilted toward each other and they'll eventually intersect. So in geometry, we've got symbols for showing lines are parallel. We can show lines are parallel in a picture by adding arrows. And what I mean by that is by putting an arrow right in the middle of the line. If If I go like that, and I go like that, now those are symbols, meaning, yep, for sure they're parallel. They're not a little bit tilted towards each other. You could go miles down the road, they're never going to intersect. So adding arrows to the line will mean that they're parallel. We can write that lines are parallel using this symbol, the parallel symbol. It's two straight up and down marks. And it's two straight up and down marks because those will never intersect. So an example of this, let's say I wanted to say these two lines are parallel. One of the lines is AB, so let's say line AB with that line symbol over the top, right, showing it's a line, is parallel to line CD, just like that. Using that symbol means parallel. All right, that's the first part of this class. Second part is just about angles formed when we have something called a transversal. So these pictures are going to be super helpful for us. You'll notice how this line here cuts across the other two, and this line here cuts across those two. Well, a line that goes across two or more other lines is called a transversal. So a transversal is a line that intersects two or more other lines. So an example, here's a line, here's another line, here's a transversal. Transversal is the one that crosses both of them. All right. When that happens, a bunch of angles are formed. I'm going to number them here. So like here's 1, 2, 3, 4, 5, 6, 7, 8, right? There's 8 on the other one as well. I'm going to start it at 9, right? There are 8 angles in each of them. So every time you have angles have a transversal, it's going to form 8 angles. There's some special name for those 8 angles. One of them is corresponding angles. So corresponding angles are angles that land in the same spot. So for example, both in the upper right corner. All right, so like if I look at this, there's 4 angles there and 4 angles there. But if I highlight one of them, if I highlight angle 2, that's in the upper right corner. So the corresponding to angle of that would be angle 6. So angle 2 and angle 6 are corresponding angles because they're both in that upper right-hand corner, right? Now, it doesn't have to be just the upper right-hand corner. It could be both the upper left-hand corner or the lower left-hand corner or the lower right-hand corner, just as long as they're in that same relative spot, that same corresponding spot. So there's lots of examples here. I could say angle 2 and angle 6. Those are corresponding angles because they're both in the upper right-hand corner. I could say angles 3 and 7. Those are both in the lower left-hand corner, same relative spot. So angle 3 and angle 7 would be an example, right? Or I could come up with all sorts of more. Just to practice, I'm going to highlight a few, see if you can name the corresponding one. I'm going to say 12. All right, well, 12 would be corresponding to 16. Those would be corresponding angles. They are both in the lower right-hand corner. What if I said 5? Well, 5 would correspond to 1. They're both in the upper left-hand corner. So angle 5 and angle 1 are corresponding angles. So corresponding angles, angles that land on the same location, right? The upper right-hand corner or upper lower left right-hand corner, etc. Those aren't the only angle pairs that are formed, though. There's something called alternate interior angles. Now, those are going to be important, right? Those ones, I'm going to put a star by that and a star by that. Those are going to be really important ones. So alternate means alternate sides, right? Left, right. Interior means inside. So if I label these again, interior, again, means inside. So if I look at these, the angles that are on the inside of the parallel lines are the angles in that area, right? These are the interior angles. So if I want alternate interior angles, I just want 2 angles that are both on the inside, but on alternate sides of the transversal. Again, and I'm looking at angles up here and angles down there. So for example, if I highlight 3, angle 3, and angle 6. They're on alternate sides of the transversal, one's on the left, one's on the right, and they're inside the parallel lines. So in that picture, angle 3 and angle 6 would be alternate interior angles. There's another pair of alternate interior angles, would be 4 and 5. Those are both on the inside as well, and inside the parallel line. So they're all alternate interior, but they occur in pairs, right? I can't say angle 3 and angle 5 because those are on the same side here. I don't want ones on the same side. I want the ones on alternate sides. So they gotta alternate interior angles occur in pairs, and they are only pairs with each other. So angle 4 and angle 5 are alternate interior angles. We don't need this one for our picture, but it'd be the same type of thing. All right. So definition, they are angle pairs inside the parallel lines and on opposite sides of the transversal. The transversal again being this line here, that line that cuts it in half. All right. Same side interior isn't quite as important as alternate interior. Like this is alternate interior is definitely the more important one, but same side interior isn't bad. It's the same type, same idea. It's on the angles that they're on the inside, but instead of being on opposite sides of the transversal, they're on the same side of the transversal. So these would be angle pairs, again, inside because they're interior, the parallel lines, and on the same side of the transversal. So if I had an example here, 3 and 5, they're both on the inside and they're both on the left of the transversal. And the other examples would be 4 and 6. They're on the same side, they're on the inside. They're on the inside of the parallel lines and they're on the right of the transversal. All right, I should pause here for a moment. I have been talking about these angles existing when we have parallel lines. That's actually a misstatement. They exist whether the lines are parallel or not. I mentioned parallel lines by accident because it turns out we really only care about these types of angles when the lines are parallel. And we're going to talk about that tomorrow. Like there's going to be something special about those angles when the lines are parallel. But whether they're parallel or not, they still are there. So like this angle, I'm going to call this 7. I already got 7. Let's call that 9 and 10. Those angles 9 and 10, those are still alternate interior angles on the inside, but alternate sides of the line, opposite sides of the line. So they're still alternate interior angles. We just don't care about them so much when the lines aren't parallel. We are almost done. We have the exact same thing as this slide here, except instead of interior angles, it's going to be for exterior angles. So I'm going to put that 1 through 8 here again on the parallel lines. If I highlight this 2 on the outside, because it's an exterior angle, which one do you suppose would be the alternate exterior angle to that? All right. Well, outside ones, these ones are on the outside, and these ones are on the outside. 2 is over here on the right side of the transversal. If I want to have an alternate exterior angle, I'm going to need one on the left side. So 2 and 7. Also, 1 and 8. Those are also on the outside of the parallel lines and on opposite side of this transversal. If you wanted a definition of that, it's the same exact definition as the interior versions, except now we're using the word outside because they are exterior versions. They are angle pairs outside. And I'm going to say parallel lines again, but it could be any lines with parallel lines. And on opposite sides of the transversal. All right, same side exterior angles. We're almost done. Same exact thing. It's angle pairs, again, outside, because that's what that exterior means, of parallel lines, and on same sides of the transversal. Let's give it a shot. This is an exact angle on the outside. Down here, do you see another angle on the outside that's on the same side of that transversal? Angle 8. Right, both on the outside, but they're on the same sides of the transversal. So an example here would be angle 2 and angle 8. That would be a pair of same side exterior angles. Over here, 1 and 7. Same side of the transversal, both on the left, both on the outside. All right, let's try a few quick examples of this, and then we're going to be done with this video. Multiple choice. Which is a pair of alternate interior angles? Again, alternate means alternate sides of the transversal. Interior means inside of the two lines. Give it a shot. I'm going to pause here for one moment. All right, let's take a look at it. 1 and 3. 1 and 3. Definitely not. Why? One is on the outside, right? Here's one line, here's the other line. I want lines that are on the inside. I want interior angles. So it's not going to be A. Let's look at some other ones. What about 2 and 6? Here's 2, here's 6. They are on the inside of the lines, right? Here's one line, here's the other line. Those are both on the inside. Are they on alternate sides of the transversal? One on the top, one on the bottom? Definitely they are. The answer to this one, C. All right, what about this one? Corresponding angles. See if you can figure out which one of these show a pair of corresponding angles. Again, I'm going to pause for just a moment. All right, let's explore it. Angles 1 and 3. Here's 1, there's 3. Over here, that's on the upper left-hand corner. Over here, that's on the upper left-hand corner. That's the same relative spot, both in the upper left-hand corner. That's what corresponding angles are. This one is angle, this one is A. All right. Which is a pair of alternate exterior angles. All right, well, this one, we already know we didn't do that one because those ones are corresponding, so it can't be that. Can't be these ones because those were alternate interior, so it's one of the last two. See if you can figure out which of those pairs are alternate exterior angles. All right, let's explore it. 6 and 7, well, here's 6, there's 7. Definitely not, because I'm looking for exterior angles. Exterior means on the outside. So it can't be that, which means it must be D. 4 and 8, let's just double check, 4 and 8. Yep, those are on the outside of the two lines, and they're on opposite sides of the transversal. 8 is below, 4 is above. Those are alternate exterior. All right, one last question. Since the multiple choice would clearly have to have been B, this is a different question. Instead of being multiple choice, it's asking what is a name for those angles. So we've got 6 and 7. So if I had those, what is a name I could give them? A special name for that pair. All right, well, they are both inside the two lines, and they're on the same side of the transversal. So those would be same side interior angles. Same side because they're both on this side of the transversal. Interior because they're both inside the other two lines, right? You have to have this line here and this line here. Those are on the inside, not on the outside. Same side interior. All right, you're going to want to practice some of this. The assignment is 3.1, page 143 and 145, 4 through 7, 21 through 24, 30, 31, 34, and 35. While you're doing these homework assignments, I would highly suggest having your notes out and just kind of having these examples so you can remind yourselves, like alternate exterior. Where were those again? Oh yeah, they were here and here, right? Might be really useful. Actually, you know what? If you had room, I might recommend one last change. Have a picture of these. So like for alternate exterior angles, just draw a picture because a lot of times it's easier to glance at it. Alternate exterior angles would be like this one and this one, 1 and 2, right? Outside the parallel lines. Same side exterior would be like, yeah, let's do that quick. I'm going to do that quick. And I'm going to save this as a sheet because it could make our lives a lot easier. So instead of just naming them and having to look at them, let's actually do a picture for each of these. All right, so corresponding angles. Corresponding angles, again, would be like 2 and 6, both in the upper right-hand corner. Right, I look at these 4, look at those 4, want the same ones in the same corner. All right, alternate interior, again, inside, but alternate sides of the transversal. So there's an example of those. All the same side interior, inside, but on the same side of the transversal. Alternate exterior on the outside, but alternate sides of the transversal, one on the left, one on the right. And same side exterior, same side of the transversal, but both outside the lines. If these pictures are an easier way for you to look at it, go ahead and use those pictures. All right, see you next time.